Math, Geometry, Unit 1, Lesson 10 is called Rigid Transformations. So our goals today are I can define rigid motion or rigid transformations. I can draw the result of a transformation in written language of a given figure, and I can explain orally and in writing a sequence of transformations to take a given figure onto another. All right, so you might ask, what is rigid motion or a rigid transformation? So a rigid transformation is a translation, rotation, or reflection. We sometimes also use this term to refer to a sequence of these. So you should by now know what these are when you arrive in a geometry class. But if you don't, a translation is a slide. So if I look here, A to B, that is a translation. So if I were to just kind of trace this figure here, and let me make that a little bit better there. Okay, if I slide this figure to B, that is a translation. Okay. A rotation is a turn. Now, in order to rotate, you have to have a pivot point. So this would be my pivot, but B to C is a rotation. Okay, so if this is my B here, okay, this pivot point, and unfortunately, this program that I'm using, it doesn't let me pick the pivot point. So picture I'm rotating it, but that point right here was going to stay fixed. Okay, eventually it would swing over right there. Okay. And then a reflection is a flip across a line. For a rotation, you need a pivot point or a point that you're rotating around. And for a reflection, you need a reflection line. So this line right here, this little green line here, I'm reflecting C to D right there. Okay. Important to note, rigid motions produce congruent figures by preserving distance and angles. So when I say distance is being preserved, if I look at this side of the triangle, when I take this whole triangle over here with this arrow, this is called a directed line segment. This side is also the same distance, okay, the same length. Okay, so when we say preserving distance, you could also think of that as preserving length. Okay, and then angles are also preserved too. So this angle here is going to be congruent to that angle. And we can kind of show you here if I just trace it, and then when I move it over here, you see that it's the exact same angle. Okay, and then likewise, this angle over here is going to be congruent to that angle, and then this angle up here is going to be congruent to this angle. Okay, so angles stay preserved, and so does distance. So it's the exact same shape. It produces a congruent figure. All right, another word is image. You're going to need to know this word. So if I'm taking this triangle here, triangle ABC, to this triangle over here on the right with this little like prime notation, we say that A is the pre-image and A prime is the image. Okay, so pre-image would be triangle ABC, and then the image would be triangle A prime, B prime, C prime. Okay, so that's the pre-image is your initial shape or figure or point even, and then the new one is called the image. All right, so in order to do rigid motion, we need to use proper language here. So if I want to translate a figure, I need to translate by a directed line segment. Okay, so if I say, if I have like this, you think it looks like a ray, but it's actually not. It's a directed line segment. So I'm going in this direction up to the right, and I end right here. So it's a segment going this way because you need direction. Okay, so if this is, B, and then this is A here where it ends, we'll call it directed line segment B, A, okay? Or maybe they might just put a letter here next to it on the side instead of actually giving it points. They could say directed line segment M, okay? So if I have a figure, let's say, I have this triangle here, right here, and I want to, it's triangle ABC. If I want to translate triangle ABC by directed line segment M, basically you're taking every point here and you're basically moving that point in that direction. So this point here, this point would go right there. And then I would also take this point right here, and it's kind of off of my page, but it would go up here. And then this last point right here, A would go from here over to there. So you have these little arrows, same direction, so that it has the same slope and same distance. But this point would be off of the grid, so not a very good picture there. But on to reflection. So if I have this same figure here and I want to reflect over a line here, let's say this is my line that I want to reflect over, triangle ABC, and this is line L. Reflect triangle ABC over line L. My figure is going to come over here somewhere. So it would look something like this. Oh, shoot, I didn't want to do that. Hang on. Let's clone it first and then flip it. So it would end up being somewhere like that. It's a mirror image across the line. And the last thing, rotate figure. So if I had this same figure here, and let's say I wanted to pivot it right here at point C, rotate triangle ABC, let's say clockwise. Clockwise is like this. Counterclockwise is like that. So you need an angle measure. Let's say I just want to turn it 90 degrees around point C. It's like my figure turns this way. This point stays fixed. Now the point could be off of the figure as well, but it would be like, and hang on, I need to make a new one. So, and again, I can't keep that point fixed. For some reason, this thing doesn't quite let me, but it would look something like that. This figure, this side goes to this side and it forms about a 90-degree angle, roughly, if you look right there. So I'm looking at this right there to there. It's a 90-degree turn, okay, clockwise. All right. All right, so on to this. What do you notice? What do you wonder? Pause the video, try to come up with some stuff, okay? All right, so first thing you might notice, parallelogram S reflects across line M to parallelogram M. Parallelogram S and M look like they're congruent. They look like if I trace this thing here, it looks like it is the same. I need to reflect it here. There, you can tell that they're exactly the same. They're congruent. What's this notation? A, B, C, D, and then this little mark up here next to the A. That's called prime. So I'd call that A prime, B prime, C prime, D prime. D is not congruent to S, but it looks similar. So same shape, maybe different size. D looks like a dilation of S or a dilation of M. What is this prime notation? I already talked about it. How do you read it? A prime. Why are these triangles, why are there triangles on the grid? All right, so here's a picture of the reflection. You can see here, the thing I want you to notice here is that these are perpendicular to the line of reflection. So I have this line here, and then this is my line of reflection. So these are 90 degrees. The other thing I want you to notice here is that these are equidistant from the line of reflection. So these are the same distance away and perpendicular, okay? Every point. All right, so draw each rigid transformation. Use the style bar to choose a different color for each one. Okay, so translate figure S along the line segment V in the direction shown by the arrow. So I'm going to trace this segment here. Okay, and what I'm going to do is I'm going to basically, oh wait, that's W, that's not V. Hang on, let's do V first. So let me go back here. So here's V. So I'm going to basically take every one of these points, and I'm going to put an arrow, every vertex on here. I'm going to put an arrow here. And all of these new points where these arrows are pointing to, those are going to be my new points. So let's get a bright color so I can see it here. So this one here, this one here, 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 here. So there's that. Okay. Reflect figure S across line Y. So here's my Y right here. So I got to go across this line. So I'm going to use maybe orange here. So I'm going to count 1, 2, 3 triangles. 1, 2, 3. This is 1, 2, 3 triangles. This point here is 1, 2, 3, 4, 5. So I go 1, 2, 3, 4, 5. Let's see here. I need this one down here. So, or I need this point here. So this is 1, 2, 3, 4. 1, 2, 3, 4. This one here is 1, 2, 3, 4. 1, 2, 3, 4. And then this last one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's that one. This one's orange. The last one was neon green. Reflect figure S across line M. So we kind of already did that. Kind of did that right here. It was different shape though. So I guess I could do that. Let's see here. We'll use purple. So I'm going to count 1, 2 triangles, 1, 2 triangles, 1, 2 triangles, 1, 2. This point here is 1, 2, 3, 1, 2, 3. This point is 1, 2, 3, 4, 1, 2, 3, 4. I need to go up here 1, 2, 3, 4, 1, 2, 3, 4, and then I think I need this one 1, 2, 3, 1, 2, 3. Okay, and it looks like a pretty good reflection there. So that one is purple. Translate figure S along the line segment W. So my W, I already had it highlighted right here. Here's my W. So I know the line segment is down here. I'm still going to move my entire figure here. So I'll tell you what, to make things easier, I'm going to trace this in red. And I'm just going to basically take this arrow here. Whoops. And I'm going to just move the whole figure. Now I know I have to move every point, but I'm just going to, for the simplicity of this, just kind of move everything right there. Okay. So there's that one in red. And how are they the same? How are they different? Well, I would say that they are turned, slid, or flipped, but all congruent. all congruent, okay? So here's some L shapes. Describe a sequence of transformations that will take figure A onto B, okay? So there's multiple right answers here. So we could, to go A to B, we could translate left. How many is that? 1, 2, 3. Left 3, down 1, 2, 3, 4, and then reflect, okay? Reflect across this line right there, okay? Now, I'm not going to write this all down. We're just going to kind of do it informally. All right, if you reverse the sequence, so, whoops, go back here. I reverse the sequence, does it still work? So I'm going to reflect it here. So if I flip this thing, so I've reflected it first, then I go left 3, down 4, and it sure does, it sure works. So the answer is yes. So now we need to go from A onto C. So let's do that. Let's trace A here. And what you guys should do at home is use some tracing paper. So get some tracing paper. They might have it at your local craft store or maybe even at, Target or Walmart. But that's what you're going to want to do. So all right, let's see here. Let's translate this down 1, 2, 3, 4, 5, 6. Translate right. Well, hang on, let me try this again here. Actually, you know what? Hold on. I might just be able to draw a line here, now that I think about it, and reflect across that line. Because remember, we said, whoops, hold on. We said that it needs to be perpendicular from every point and the same distance. So a little off on my line here, but maybe if my line was like right about here, these are pretty close to being equidistant and they look perpendicular. So it looks like I'll reflect across, and every point that you reflect is going to need to be the same way. So like these need to be equidistant and perpendicular and so forth. Okay. Actually, I don't really have anything to reverse here the way I did this one. So yeah, it's still definitely going to work. So, all right. Reflect across this line. So again, you're just kind of counting. You got to be perpendicular. You got to be equidistant. So this is 1, 2, 3, 1, 2, 3. This is 1, 2, 3, 4. 1, 2, 3, 4. So these are all my points here. So this one was here. This one was here. Man, that's sloppy. Let me redo that here. Use this tool here. This one that might help. There you go. It looks a little bit better. And sure enough, it does look like a reflection. And again, important to note here, like this point here, C, if I call that C prime, this one I call D prime, this one goes here, this becomes A prime, and this one B prime. That's a good notation to use. All right, so back to our goals. I can define rigid motion or rigid transformations, rotation, reflection, translation. I can draw the result of a transformation in written language of a given figure. Still kind of developing this, didn't really get into too much depth with that. And I can explain orally and in writing a sequence of transformations to take a given figure onto another. Okay, again, still kind of developing in this lesson, but we will do more and more as we keep going. So check out my next couple lessons as we go. All right, thanks for watching, and we'll see you next time.